recording. And with that, I'll hand it over to Brenna.
Thanks. So today, I'm going to be talking to you about the case for on-prem Iceberg and breaking down the reasons why you might want to build your data lakehouse on-prem for cost, performance, scalability, and security. So I'm going to go over some key challenges for Iceberg cloud data lakehouses, stuff we're all familiar with, limitations of the cloud, and why moving workloads back on-prem might be your solution to these challenges, why you should believe us, MinIO, when we tell you this is true, and then break down the reasons why on-prem storage beats out the cloud in terms of performance, scale, cost, and security. And finally, I'll show you some real-world architectures from enterprises like yours that have built on-prem or hybrid lakehouses on Iceberg. So we're going to ground this conversation in some real-world challenges that come from building data lakehouses in the cloud. And we've interviewed hundreds of customers that are experiencing these challenges, and we've broken them down into two main buckets: affordability at scale and data control and governance, security. So we'll start with the cost, affordability at scale. Public cloud costs, as we all know, are really highly variable. You're billed for the storage, of course, but also retrieval, the API calls. Every time you do a put or a get on top of your data, any transactions that you make, you get charged. And that's not to mention egress fees when you're taking data out. If you got a hot data, like in a data lake house where you have a lot of transactions, you're going to get a high bill. It just adds up quickly. So another cause for skyrocketing costs in the cloud are well-meaning security measures like redundant backups, region-level compliance, things that you think you need but really add to your scale when you're working in the cloud. And then you have things like infrastructure sprawl. So this is a really common thing that happens in an organization where individual work groups within an org create their own data clouds. Marketing has their own lake, sales has another, and they're all siloed and they don't talk to each other. So all of this really adds up, and it's sort of a rite of passage for every engineer to get a really scary cloud bill. Everyone has gotten one. And for some burst or cyclical workloads, these kinds of costs might be inevitable. You're going to spin up and shut down a big cloud instance or a small cloud instance, maybe for a one-time use case, maybe it makes sense. But when we start talking about enterprise-wide data initiatives, type of data clouds, data lakehouses that span an entire organization, the kind of data centralization that we all aspire to, the cost just becomes unsustainable. All right, so that's challenge number one. Challenge number two is going to be data control and compliance. So this is security. And for many organizations, this is the primary reason why they haven't even moved their workloads into the cloud in the first place. They have really sensitive data, things like patient records, financial transactions, proprietary IP. Their government agencies, their utility companies, their banks, they literally cannot move their data into the cloud. And some of the most valuable insights can come from these really sensitive data sets. It's sort of the cost of doing business here. So the data needs to stay on-prem to meet regulatory or internal compliance requirements, but you need it to actually do the kinds of initiatives that you want to do. AI, record keeping, analytics, literally anything that you want to do with your data. And protecting that data isn't just about encryption, it's about access control, it's about auditability, it's about being able to enforce governance, all in your own environment on your own terms. And you can't completely solve security and compliance issues with a shared responsibility model as you have in the cloud. It's not possible. So where do you go from here if this is your challenges that you're facing, as many of our customers that we've interviewed experience? Well, perhaps you go on-prem. So let's talk about scale. The largest private cloud data lakehouses in North America are all built on on-prem object storage, because scalability doesn't belong exclusively to the cloud. It's more of a design principle. Though obviously not all object storage is built the same. So it's important to choose the right object storage from the start. And there's two reasons for this. First, it turns out to be very hard to move data once you've selected a place for it to go. And secondly, with modern performant object storage, you can scale both your storage and compute separately. So you can add more to your compute if you have a heavier workload. You can add pools to your storage if you need to. Scale goes both ways. So an Iceberg deployment should be able to deploy on minutes, whether that's on your laptop or in a colo. It should just work easily as you think it should. And it should be something your existing DevOps personnel should be able to do. So cloud native skills are transferable across software. You don't have to hire something that has a diminishing skill set to manage workloads like this. If the object storage or the underlying foundation of your data lakehouse is built for the cloud. So next is performance, and Iceberg is fast, no doubt, but Iceberg's optimizations can only take you so far. High performance object store delivers 2.2 terabits per second throughput, ensuring that your queries, your AI training, anything you're operating on that data is as fast as you think it should. They don't get bottlenecked. And high performance object store maxes out your networking, whether that's 12 nodes or 550. This proves that on-prem Iceberg deployments can be as fast as the cloud equivalents. So security. So on-prem means full control. We talked a little bit about that when I was talking about the challenges to cloud, but on-prem means full control. So you can keep all of your most sensitive data in a controlled namespace. You can ensure any compliance with any regulations you're required to, GDPR, HIPAA, SOC 2. Your object storage should have multi-tenant isolation, and you should have fine-grained access control on every part of your objects, from object level on up to your logins, right? Users, buckets, it should be completely within your control to manage. So let's talk about cost. So modern object storage software, it's going to be the best TCO at whatever scale you operate in. It's meant to operate in whatever scale you operate in, from big to large, from however big or however small you need it to be. So there's no egress fees, obviously, it's on-prem. You don't get hit with costs for your gets or your puts every time you transact over that data, and hopefully you're transacting over it quite a lot if it's for your data lake and it's operational for your entire enterprise. And you could amortize the cost of the hardware over time. So your data infrastructure bill goes from being spikes to level, right? You know exactly what to expect every month. So why should you believe us? I'm up here talking to you guys about data lakes. And MinIO AI Store, the de facto standard for object storage, this is a little bit delayed, we've got 2 billion, upwards of 2 billion Docker pulls. We've filled a lot of data lakes. So we're here talking to you about experience on the ground. This is boots on the ground information that we want to give back to this community. We're the most highly awarded object storage on the market. We're just object storage, that's it. And we really value giving back to the developer community. So it's goodwill. It's our information to you, all right? And about me, I should have said that. I'm a data engineer with about 12 years experience. So I love data lakes, and I've been building a lot of them. And this is all information from learned experience. All right, so another thing is we are first-class partners in all the key technologies of the Iceberg Data Lakehouse. This is not a complete diagram. It's just representative of the partnerships that we built here. Like I said, we have a lot of goodwill. We just work out of the box. We work with almost everything. We're really proud of these relationships. So, and we're happy to share that relationship with you guys. Okay, so performance and skill. So now we get to the breakdown of why on-prem might make sense for you. And we'll start with performance and scale. And I put these together because in my mind, they're interconnected. They can't have one without the other. So the first thing is Ethernet is the way. So RDMA over converged internet lets us move data at terabit speeds across Ethernet infrastructure. The reason why we support this is because it's cost-effective, scalable, and future-proof. It's a standard. So we at AISOAR conform strongly to the S3 API. And of course, we support the open standards like Iceberg. When we as a community can support and rally around a single API or a standard, it lets vendors really focus on what drives the needle for our customers. It lets your engineers focus on what drives the needle for your business rather than learning a new standard of interacting with your data or other appliances or applications, right? Standard is good. Standard means better experience for everybody. So it means you're not locked into a proprietary fabric. You don't have to learn anything weird or new. And when you're hiring for the devs to operate on your data lakehouse, you're not trying to hire a specific niche skill set. Everybody knows the S3 API. Everybody knows the Iceberg REST catalog, right? Everybody knows S3 over RDMA because it's like 20-year-old technology, right? So standards are good. It's also multi-vendor. It's really widely adopted. And it's very high speed, low latency. It's especially good for AI workloads. So, speed matters. It's not just for training models, but for scaling massive data lakes. It's for serving real-time dashboards. When speed matters, this standards matter, right? So with a 400 gig E or 800 gig E networking, we can move data with incredibly low latency and really, really super high throughput. So that means everything goes faster. In S3 over RDMA, you're bypassing the CPU and go right to direct memory access. So you go right to the GPU. And so instead of pushing data to the TCP IP stack, it moves memory to memory with zero copy transfers. That's how you get that speed. That's how you go that fast. So this is a critical component of what makes on-prem data lakehouses so fast. All right, so, and when people hear on-prem, they often, let's be honest, they often assume limited scalability. And this is because they're remembering older technologies with different limitations. So modern performant object storage, the narrative is completely different. So this diagram represents a typical scaled out deployment for AISOAR, but it could be, it's representative of any modern performant object storage. It's built for throughput, it's durability, and simplicity. So each rack contains one or more storage pools, and they're made up of erasure sets. So this provides the building blocks for your underlying storage for your data lakehouse. There's a global load balancer on top, which sits above the racks, and it unifies them into one or more namespaces to the application layer. So that could be whomever. We have showed you the slide that has all our partners. It could be Trino, it could be Spark, it could be Iceberg, it could be Snowflake, it could be whoever your compute layer is. The result is really modular linear scaling. You can add racks, you can add hosts, you can add drives. Everything just works. It's a cloud-like experience. So this is really important to the experience of implementation, and for upgrading, it should be easy, it should be simple. And your existing DevOps personnel should be able to do this. So this design also makes it really easy to modernize. So you don't want to run on 10-year-old hardware. You want to be able to swap out racks or disks easily. And because the system outlined is modular, you can swap and drop. It makes it really simple. All right, so start where you intend to end up, right? Start with a foundation that lets you modernize at will. So this isn't just theory. We've proven this architecture at extraordinary scale. So this is an example of a customer. It's an auto manufacturer in the United States. It's the largest MinIO deployment to date. It's a 520 node cluster. It delivers 3.086 terabits with every get and 3.138 terabits per put. So it's super duper lightning fast. It's huge. It's 340 petabytes and growing. They've got an exabyte scale potential with the hardware they have. This is faster. This goes faster than most networks can handle. And in fact, AI Store often maxes out, maxes out the network at 400 gigabytes per second networking infrastructure. So when you pair Iceberg with this hardware and software, you can go as fast as you need to. And we've brought customers there. So costs. This is a biggie, right? So we talk about performance and scale, all good. Let's talk about costs. So this is about time to value. So one of the most underappreciated advantages of on-prem is you can get up and running really quick. And how fast you can get up to running translates into real measurable value. So this is time to value, or TTV. So TTV refers to the period between when you start deploying a solution and when you actually see a benefit from it. When your deployment actually produces results, you're actually operating queries over this, your Iceberg lakehouse is up and running, and people are oohing and awing of how fast their queries are going. It's not just about standing up the infrastructure, it's about seeing the results of that. So we've heard from our customers, like I said, we've shown you, we stood up quite a lot, and we've asked them afterwards, what was your experience like? How soon were you able to see value after you implemented? And 50% of our customers said they saw value within 12 months, that's incredible. This is storage. So this is moving from things like Hadoop into like old legacy architectures into object storage. This is just for storage. So this is value for storage in 12 months. And even more impressively, 36% saw the value in under 3 months, and the rest of them they haven't fully implemented yet. The ones we asked, but we expect to see even more results like this one. All right, and there's a few reasons why MinIO plus Iceberg can deliver these results so quickly, why this value comes so quickly, and the first is that installation is simple and repeatable. And I showed you what that architecture looks like, that swap and drop modular linear architecture. This means you can scale from one rack to hundreds without changing your deployment model. And second, we run on standard storage hardware, commodity hardware, stuff off the rack. So you're not going to spend a bunch of money on a proprietary hardware. You can have multiple vendors compete with each other to find the best cost for your hardware. You can act like the hyperscalers. Your private cloud should be as operationally efficiency as the hyperscalers. You know what I'm talking about. All right. So, and third, you can adopt incrementally. So you can, you don't have to re-platform everything. You can just deliver faster performance, get your queries off the ground. It means you can set up your storage. You can set up your data in Iceberg, and then you can pick out which query engine or compute you want at whatever one you want. You can swap and drop your compute engines too. We work with everybody, right? So this is commodity in two places, right? In hardware and in your software that you access the data from. That's what makes it so fast. That's what makes it so successful. All right, let's talk about cost. And really, this is my favorite slide. I feel like I should have I could just show this slide and then walked away, and I would have had as valid a presentation as this whole thing. But I really want you guys to focus on the upper right-hand corner. That was the best one. And what you're seeing here is annual storage costs on the y-axis and data capacity in terabytes on the x-axis. And the blue area, of course, represents the public clouds. And the red, this is object storage costs for both. The red area is a private cloud or on-prem object storage on commodity hardware, including colos, right? Drives, the subscription, everything, all included costs. So up to a certain scale, it's pretty comparable. You see it's pretty stately, steady. But around 5,000 terabytes or 5 petabytes of data, there's a clear inflection point. It just goes, right? That's where it is. Mic drop, that's it, right? Like this is your cost savings, right? If you have, this is hot data too. So listen, if you're gonna have 5 petabytes in the cloud and you're never gonna touch it, it's gonna go in Glacier or whatever, maybe it's cheaper, okay? if it's gonna be hot, if it's gonna be for a data lakehouse and you're transacting over it and it's above 5 petabytes, that's it. There's no question. It's cheaper on-prem, including your hardware, including your subscription. All right? So that's it. This is my favorite slide. Okay. All right. So we'll talk about security, right? This one's obvious because the gold standard for security will always be an air-gapped environment and total isolation, right? No external connections, full control over your data, your infrastructure, your access. This entire AI architecture model can be deployed in an air-gapped environment, and it'll work exactly the same day as you installed it, okay? 350 feet underground, covered in concertina wire, whatever. This will run perfectly for you. I mean, that's it. I mean, that's amazing. This is amazing. There's no cloud dependencies here. There's no outbound API calls. There's no risk of exposure. You just have deterministic, enterprise-grade, self-hosted AI and ML data lakehouse. All right, this is cool. This is my second favorite slide, I would say. All right, architecture. So these are real-world architectures from our customers that have actually built on-prem and/or hybrid data lakehouses. Okay, so these are actual customer stories. So this is a real-world architecture from a shared customer with Dremio. It's Memorial Sloan Kettering Cancer Center. And this is a really great example of an fully on-prem data lakehouse built on Iceberg. So it serves up mission-critical, very highly sensitive use cases. So at the core of the setup is an Iceberg data lakehouse with MinIO as the object store and Dremio as the query engine. This particular architecture ingests large binary objects like pathology slides and genomics data, but also tabular metadata from systems of record. Let's see, this architecture supports it's a true data mesh, okay? So decentralized teams can all query from across the organizations, can all query from this data lake with whatever tool they desire. So I think that's the best part. Without creating copies. You don't have to move your data around, it stays in one place, there's no copies. Copies means duplication, duplications mean money, right? So no copies. And they don't have to build any custom pipeline unless they want to. This lakehouse is deployed completely on-prem, ensuring complete data sovereignty, complete data security for this sensitive healthcare data. And in cancer research, which is what this is for, time to value actually has meaning that you don't experience too much in regular business. It doesn't really matter if your deployment to production gets delayed in most use cases. This actually saves lives. So it was important that this get up and running and actually have value to the business in a tangible human way. So this is great. This is another one. So this one is Nomura. It's also another shared Dremio customer. This is a real Iceberg data lakehouse that exists in the wild today, a shared customer between us two. This is a hybrid model. So they have some data in S3 in Amazon and some data in MinIO on-prem, and they're able to operate them efficiently because MinIO has a single platform to observe and monitor and manage all of your deployments across any channel that you have. So if you have some data in the cloud and some data on-prem, this could be your solution. So the takeaway is that this gives you flexibility. These are real things people have done. Just wrap up with some takeaways. So scale is real. Every enterprise is dealing or will be dealing with petabytes of data in the future, hundreds, exabytes. So the petabyte is the new terabyte. You might put that on t-shirts. That's pretty good, right? Older systems aren't built for this kind of scale. That's just the reality. They're just not built to go this far, this fast. You need on-prem infrastructure if you've got that kind of scale, and you need something that has the performance to handle the kind of workloads that you want to do, like Iceberg data lakehouses, without falling over. And I gotta be honest, that's like 90% of our customers who have tried something else it falls over, they come to us because we work at scale. So, you just can't, the final thoughts, you can't throw hardware at a broken system. You can't just keep adding disks to something that's not meant for the modern infrastructure. And you need to get your storage software right. It needs to be software defined, cloud native, AI first. Otherwise, you're just going to end up building everything from scratch every couple of years. So this is my take. Thank you so much for attending my session. Please come by our booth. We have T-shirts. And this is a white paper that you can access that has more information about our product and how to build data lakehouses on-prem.